The experiment name is distribution of acetic acid between N-butanol and water. Here, the aim of the experiment is to determine the partition coefficient Kd for the distribution of acetic acid between N-butanol and water. Okay, N-butanol and water. Okay, it is an organic compound. It is inorganic. Both are immiscible. Like if you mix the water and kerosene like that, it will immiscible liquids means both are not miscible. Okay, not both won't be forming a same type of a liquid. Okay, we can able to see the two layers, like when you add any oil to the water, kerosene, like that organic compounds, when you add to the water it will form a immiscible. They won't mix with each other. Like if you add to the water, if you add sugar, like that they will mix. But like if you add milk also, you will get the miscible liquid to the water if you add milk. But for in case of immiscible liquids, we are going to find out the distribution, how it will be distributed if you are adding any other liquid to that. Here we are getting taking two liquids, N-butanol and water. What is the principle in this? When two immiscible solvents are put in contact with each other and a solute soluble in both the solvents is added, the solute distributes itself between the two solvents in such a way that the concentration of a solute in the same molecular form in the two solvents or in a constant ratio at a given temperature. According to Nernst distribution law, at equilibrium, C1 by C2, concentration in one layer by concentration in another layer is equal to distribution constant, where the C1 and C2 are the concentration of solute in two solvents. Okay, in case of acetic acid, its concentration in organic and aqueous layer can be determined by titrating against NaOH. Okay, here we are taking two immiscible liquids, that is N-butanol and water. We are mixing both each other. It will form a immiscible liquids. Okay, means both won't be mixed with each other. Here to that you are adding acetic acid, and how the acetic acid is distributing in the both the layers. Okay, according to Nernst distribution law, the distribution will be equal in the two layers at a given temperature. Then in that case, the distribution law is written as Kd is equal to C1 by C2. Here we are going to find out that. Okay, that is the principle involved in this experiment. Okay, then what is the procedure? For this doing experiment, we will take two reagent bottles. All of you know the reagent bottles. Reagent bottles, it will be like this. Two reagent bottles will take. Okay, in a reagent bottle, first we'll take 50 ml of butanol and 50 ml of acetic acid solution, and we are mixing well both for 15 minutes, then allowing them to settle down for some. Will allow them. Okay, in this procedure we are taking 50 ml of N-butanol and 50 ml of 5% acetic acid, means acetic acid which is dissolved in water. Okay, we'll take. Okay, then we'll shake for 15 minutes. Okay, allow the two layers to separate. Arrange a burette containing M by 10 NaOH. We'll take in burette, we'll take NaOH, and in the reagent bottle we are going to take N-butanol and acetic acid, and we'll shake for 15 minutes and we'll keep it aside. Okay, then the two layers will separate out. Okay, they will set down. Okay, if you keep aside for some time, then you have to take from upper organic layer 10 ml you have to take into conical flask. Okay, we need two conical flasks. First step we take reagent bottle. Next step we are taking two conical flasks. We are taking two conical flasks. Okay, in that, okay, whatever the two layers are there, from the upper layer is organic layer. From that you will add 10 ml to that. Okay, then phenolphthalein indicator and titrate against the NaOH. Okay, that is the second step you are doing. Okay, then in the third step you will take another conical flask. In that you will take from the bottom layer, aqueous layer you will take aqueous layer. To that again you will add the phenolphthalein indicator and titrate against NaOH will record the value. Then we'll note down in the table. Okay, this is the observation table we are maintaining for this experiment. Serial number, upper, lower. Okay, V organic, V aqueous, and the KD is equal to V organic by V aqueous. Like that, we'll do the first titration. Okay, I'm repeating the procedure. First, you have to take a reagent bottle. In that reagent bottle, 50 ml of N-butanol, 50 ml of 5% acetic acid. That means acetic acid which is dissolved in water. Okay, means in the reagent bottle three chemicals are there. Okay, acetic acid is there, water is there, and butanol is there. Okay, then after that you will shake for 15 minutes and we'll keep it aside for a minute. Then let them settle down, two layers. Then we have to collect the two layers separately into two different conical flasks. First upper layer 10 ml, then into the other conical flask lower layer 10 ml. Okay, to that we will add phenolphthalein indicator and we'll titrate and we'll note down the value. Okay, that is the first titration. Okay, next time again what you have to do to the reagent bottle. Okay, to the reagent bottle for the second titration. To the reagent bottle we will add 10 ml of N-butanol and 10 ml of water. Only water we'll add. N-butanol and the water we will add. Okay, again 15 minutes we will shake it and we will keep it aside. If we will use the shakers for shaking for 15 minutes. Okay, then we'll keep it aside. Again same. Collect the organic layer and the aqueous layer 10 ml into different conical flasks and add phenolphthalein indicator and titrate it against NaOH. Okay, then after you are getting the values you have to note down, and for third titration again you have to add to the same reagent bottle. Every time you are adding 20 ml you are adding. Okay, 10 ml of N-butanol, 10 ml of water you have to add. Again 15 minutes you have to shake it, then keep it aside. Collect the upper layer 10 ml to the conical flask, add phenolphthalein indicator, titrate it against NaOH. Then next aqueous layer collected, add phenolphthalein indicator and titrate against NaOH. Okay, by using phenolphthalein indicator. Like that if you have to repeat for 5 times. Every time you are adding 10 ml. Okay, first time you are adding taking 50 ml. From second titration you are adding 10 ml to that. Then you have to calculate the values. KD is equal to V organic by V aqueous. The titer value of organic layer by titer value of V aqueous. Like that we are repeating 5 times. Then we will take the 5 times average, means all 1.05 plus. These are the values I took. For example, if you are getting these values, all the values, sum of all these 5 values by 5 are there, that's by 5. 6.4 we are getting for this, and by 5 we are average we are getting 1.3. Okay, average of the distribution is 1.3 we are getting. Then we have to draw the graph for this experiment. We have to draw a graph between V aqueous and V organic. Okay, V aqueous on the x-axis, V organic on the y-axis you have to take. Okay, we can see here the values based on the values V aqueous and V organic. 36.8, 36.4, 29.7, 23.1, 19.6, like that they are there. Okay, means here we took a scale 2, 4, 6. Okay, always when you are taking a scale, see the what are the minimum and maximum values. Okay, here our maximum value is 36, minimum is 19, minimum is 13 here, maximum is 37, minimum is 13 is there. Then here we took the scale equally like 2, 4, 6, 7, 8, 10, 12, 14, 16, 18, like that we took. Okay, all the values, same scale on the y-axis, 2, 4, like that we took, and we are pointed all the points what are there. Okay, means on the x-axis, okay, 36.8, Okay, 36.82, we are correlating that. Okay, like that you have to keep all the points, okay, to the 36.8, 36.8, 36.4 to 28.9. Okay, means x-axis if 28.9, if you are taking here 28.9. Okay, first one I'll show 36.4. Okay, on x-axis 36.4 and okay, v aqueous, first I'll select this point, I will show 28.9 to the 36.4. Okay, 28 point means here 28, to that you have to correlate the point 36. Okay, here see, here this point is the 36.9. Okay, like that. Okay, like that you have to keep all the points and draw a line from the center. Okay, we'll get a straight line which is passing through the center. Whenever you are drawing that line, see that whatever the points are there, the maximum point should pass through that line. Like that you have to draw the straight line. For example, if I have a point here, okay, one point here, another point here, okay, then I have to draw a straight line which is passing through the center. Keep a scale, okay, like this, that should pass through that line. Okay, then after that take any 2 points on this line. Okay, already which you got the same points you can take, or other points also you can take. Select any 2 points on that. Okay, then for that you have to draw the lines to the x-axis and y-axis. You will get x1, x2 like this. To that if you are correlating to y-axis, you will get y1 and y2. Lower value will be 1, higher value will be 2. Here also lower value will be x1, higher value will be x2. Okay, then you will, by using a slope formula, y2 minus y1 by x2 minus x1, will calculate and will get the k value from the graph. Okay, for every graph you have to write the heading and the scaling, x-axis and y-axis 1 unit. Okay, one, whatever this one box is there, we'll call it as a 1 unit. Okay, 1 unit. 1 unit is equal to how many you are writing? Okay, we are ml, no? 1 unit is equal to 2 ml. Okay, 1 unit is equal to 2 ml. You have to write. Okay, this is about the distribution of acetic acid in between N-butanol and the water. Okay, the graph and the table and principle and procedure of the acetic acid between N-butanol and the water.